I am a co-founder and chief technology officer at Trapview. And at Trapview, we are dealing with automated monitoring and prediction of pest insects. But before we dive into it, let's first check how things are done at the moment. And the easiest way to explain this is through an example that everyone knows. That example is navigation, right? So if I would come here by car, I would put in Google Maps, what's the route, and it would take me around 11 hours, about 1,000 kilometers. But what I would also get is this kind of list of instructions. Where should I merge to another highway? Where should I turn left or right? And of course, in real life, I would go in the car and I would start the GPS navigation. However, there is another way to do it, and that would be I would just look at those instructions, and I would look at how much the distance I already traveled, and then make the turns according to those instructions. That seems very awkward and not really useful, but in reality, that's how most of the modeling in agriculture actually works when it comes to modeling of pest insects. Because what we do is we study the insect, and we know that it's related to the accumulated temperature. So we have degree day model, which is an instruction. And then what we are really doing is we are measuring how much temperature was accumulated. And based on that, we do our decisions. Clearly, there is no GPS effect into it, right? We don't know what is really happening. We just know what could happen or should happen. So for that reason, we also have monitoring. And monitoring has been around for a long time. But manual monitoring means you have to go in the field, you have to check your traps, or you have to do the field scouting. But monitoring is the cornerstone of every modern integrated pest management strategy. Because this process is time-consuming, labor-consuming, we want to automate that, and that's what we are dealing with. When we are looking at monitoring, we realize that that's really a data management process. So, like with any data, we have to collect it, we have to purify it, and then based on this, we can get insights, we can get the predictions, what will happen, so we can enhance the data. When we have collection of the data, what we really want to do when it comes to pest insects. You have to have something that is efficient and that it is independent. By efficient, I mean it has to be tailored to the needs of individual insects. There are around 1 million known species of insects, one of the most diverse family of animals in the world. So thinking that you have only one model of a trap that would fit to all different needs is just naive. That's why you have different models. Here, a couple of them are shown. It's also a topic I could talk quite a lot about, but maybe it's better than to stop by at our booth, which we are just around the corner. The other part is independence. By independence, I mean you don't want to go there and check the traps. You don't want to go there and charge it or export the data from the trap, in our case, images or something like that. So these devices need to be energy independent. They need to send the data over in a standardized way, in our case, over cellular network. And also, you don't want to go there and change the sticky liner very often. So that's why you want to have the self-cleaning feature of the trap. This is those white boxes you see at the bottom. So when you have all this in place, then you can say, yes, now I have an uninterrupted inflow of the data coming in. The next step is how you purify, what you do with that data, what you do with those pictures, how you separate the signal from the noise. We are based on images, right? You can also have some other sensors, but images give you the best validation option available, and also you can have the history data and so on. So just to check, because it's about lunchtime, your guess, this is a real-life picture from the light trap, which is more broad, right? It's not very specific to a specific species. The attractant is not specific. And the insect in question here is European corn borer, Ostrina nubilalis. And since it's a light trap, it gives you both males and females. So, quick check. How many of the European corn borers are here? 22, you were right, whoever did. But it's a good example of why this is a tough problem for image recognition, why this is a tough problem for deep learning that we are using. And when we look at how accurate the recognition is, we are always, or very often, referring to what's the average accuracy. Is this 70, 80, 90% perhaps? But what we should really ask ourselves is, what is the worst case scenario? Because those bottom peaks, this is the accuracy level, by the way. Those bottom peaks are the important ones. And that's the reason why we also have the manual validation of people who are validating what was the output of algorithm, so that we are always above 90%. Why? Because that's the difference between I can trust the data, I did the data purification properly, or I have to look at pictures, because I don't know when this happened, when it was tough for the algorithm to be accurate. Okay, so now we have this uninterrupted flow of input data. We have purified it in a proper way. So now we can get some insights. Now we can get some prediction. And the output of those first stages is the daily catch. But in reality, daily catch is only one important, yet only one part of the big picture of the puzzle. Because what we should also consider is how we create time series. The distribution of an insect population is very uneven. You would have lots of catches today, almost nothing tomorrow, and so on. Lots of those zigzags. So you have to create a longer time series to understand what is the trend. The other thing is, we have to take into consideration the insect development itself. You know, with humans, when we say, okay, we are born, we are young, we are teenagers, and so on, those transitions from one, let's call it stage, to another take years. With insects, it takes days, maybe weeks. So we have to take this into consideration. Otherwise, we would say, oh, let's just create a really long time series, and that's it, right? It will be the most accurate. No, because the population will change in the meantime. One thing that has always or also been of quite a big challenge when we look at the data is the pheromone change. Usually when you change the pheromone, you have a false peak. But it's not always, right? So how to determine from the data when this happened, when it is in line with the actual increase of the population, or when it is just because we released most of the pheromone at very short time period. What also plays a major role, and I mentioned this a couple of times, is weather, right? Insects are cold-blooded animals, so temperature is the major factor into this. It also helps a lot when we have data from other traps, when we construct a grid or a network of traps, because that gives us a better understanding of what's happening in one area instead of what is in one particular point. And the last one, yeah, we do spraying, right? We do crop protection, and that the goal of that is how we can impact the population to the levels that it doesn't make problems anymore. So when we look at the whole picture of what we have to take into consideration when understanding the pest population, it's not just I do the daily catch, right, or I do the weekly catch. It is all other aspects that we have to consider as well. And once we have this, then we have a good foundation to predict what will happen. And what you can see then is in different places, you have eggs, you have early stage larvae, you have late stage larvae, you have pupas, and also you have relative intensity, so relative to other traps. We don't know, what is the total intensity or the total number of insects in one area, because it's just not possible to do that, but we can compare it between different monitoring sites. And with the help of machine learning, you also have a very good prediction of how the insect will behave in the future, when you will have eggs, when you will have different stages of larvae. And we can predict that for the next 7 days, because that's also the time period in which we have good weather forecast. So that would be in a nutshell. Probably you would have some questions as well, huh? Or not. Okay. Yeah, everyone, I mean, we can discuss in more detail. Stop by, we're close by. And thank you for your attention.
You caught me with a cup of coffee. Oh gosh, I'm late. Thank you so much. You did what? Say it again.
I did a quick check if someone's asleep.
No, we were all listening, but I was. Have you seen me running behind the lady in red? No. Again, your booth and all the question that also comes to you. Who do you need to meet here at Fruit Logistica? Who would be a perfect match?
Well, vast majority of our users are crop consultants, because these are the people who tell the growers what to do and so on. So, yeah, whoever is in this segment, but also growers who want to better understand what is happening in their orchards or fields, or different crop consultants. Yeah.
Okay, so you all invited. Please come around and meet Matej Stefancic. Thank you so much.